Okay, looking at the homework from yesterday, area of a region between two curves. We'll start by doing 6, 7, and 8, and then we'll see where we stand if you want to do more. We need to do those hard ones on the back. But let's start with 6, 7, 8 and see sort of what it looks like after that. Doesn't give you much room, but you can write small, and I can zoom in. All right, square root of 3x plus 1. And, this is calculator, so you don't have to, I guess in theory you'd know how to graph that. Maybe, but why bother? Let the calculator do it. I have no idea about what my window is, so I'm going to go zoom standard to start with, and we'll see if, what I need to change. Okay, that's not a bad window. I see the area that we're talking about right in there. So I could just leave that and be fine. If you want to mess around and get a better picture, that's fine. You know what? I think I don't want to mess around. I think I just want to graph what I got. Plus 1, so I'm using a little bit of my own knowledge here. It's not going to start at 0. It's going to start at up 1. Go like that. But x equals 0 is one of the boundaries as well. So what I really need to find is where they intersect over there. Second calc, intersect. Again, if there's only two curves, it's easy to just hit enter and enter. First curve, second curve. And then guess, go get kind of close to it. Hopefully it's something nice, but it's not something nice. That's okay. 4.79128 ... If we want to make sure we're really accurate on this, we can store that. That way I don't have to type in all those letters. So you exit out to the main screen, store it as A, and then I can do, in fact, if I'll label it A right here, then I don't have to write that number ever again. I can just write A every time. That's encouraged on the AP test, as long as you label what A is. If you don't label what A is and then you just start using A, the grader will probably know what you're talking about, but they can't give you credit unless you tell them what A is. So 0 to A. And we can even use Y1 and Y2 as long as we label them Y1 and Y2. Again, so that the grader knows who you called Y1 and Y2. I bet I have an integral somewhere close of Y1 minus Y2. And I want to go from 0 to A, Y1 minus Y2. Oh, by the way, someone later yesterday showed me an easier place to find the Y variables. It's F4 or F5, I don't remember. F4. So if you go alpha F4, you immediately get your Y variables. So that's kind of convenient. So this one was Y1 minus F4 Y2 dx. Have to think for a little bit on that one. 5.423. And that should be accurate to 3 decimals because A was accurate to whatever, 8 or 10 decimals. So I'm not worried about that answer. I'm not worried about me having rounded anywhere. Right, number 7 is one I had flagged from the get-go to look at. So I know what the cube root looks like. Let's see, x to the 1/3 for a cube root, and y equals x. And this is one where the window is not very good, the standard window, because I don't know what's going on in there. So let's maybe go -2 to 2 on x and y and see if that looks any better. Okay, that does look better. Now, I suspect some of you, you wondered why you had to multiply the answer by 2. Does this picture answer your question? Because a lot of times people just do one piece of the area rather than both pieces of the area.
I guess that's the exact same, but I just did the addition thing with the y's with the y1 and y2. So it was like -1 to 0, y2 minus y1 plus 0 to 1, minus y2. Did I just do extra work? Or?
No, there's like 2 ways to do it. That's really the way we did it. We said there's 2. Let's see. So that would. I don't need the calculator for this one. Where does the cube root of x equals x? That's at 1 and -1. So you can do intersection if you want to, but sometimes it's easier to just look at it and think about it. So 2 ways to do this. The way that would match what we did in class yesterday would be from -1 to 0 of, be careful here, the top one would be x, so y2 minus y1, plus 0 to 1, and then they switch places, so y1 minus y2. But what you sort of figured out, or what you noticed is, despite my drawing here, those areas are equal because of the symmetry. So if you wanted to not put all of that in the calculator, and you just wanted to put one of them in and double it because of the symmetry, that's okay. In fact, you could even sort of, cheat the grader and write this as your answer, but then realize, oh, I don't really want to type all that into the calculator. I think I'll just double one of them. Y1 minus y2, so that would be 0 to 1, but that's only the right hand side. Which this brings up an interesting. Your calculator does it numerically. It doesn't do it symbolically. It doesn't actually take an antiderivative. It does a Riemann sum where it draws 1,000 little bitty rectangles in there and adds up their area. What do you think this answer is supposed to be exactly? I suspect that answer is not exactly right. I bet it's 1/4. And to 3 decimals it is 1/4. But this illustrates the calculator doesn't get a perfect answer. But that's only half of it, so I'll multiply by 2 and get 1/2, or at least 1/2 to the nearest 3, 4, 5, 6 decimals or so.
So if it gave you, also after those 2 equations, it said x equals 0 and x equals 1, then you would only do right?
Yes. If it said, that's a good question. If it said x equals 0 and x equals 1, then you would only do the right-hand side. But it didn't say that. Previous year's test have a question sort of like this, and you can bet that a common wrong answer is only doing half of it. And I don't know, that kind of confuses me because you have a calculator, so you put it in and hopefully you immediately see that there's 2 pieces to it. Number 8. I think the easiest way to work the x equals problems is to say, you know what, I don't like graphing with x. If I switch everything, if I switch all the x's and y's, then my graph is sideways, but my area is still right. So I think that's just how I would work this problem. Just switch everything. Again, your graph is going to be like sideways, backwards, but that's not what's most important here. Y1 and Y2. Again, make sure you label which one's Y1 and Y2 if you plan on using those abbreviations later. Negative x. Okay, my window is not great. I need to go over to the right some more. So maybe to 5, and it looked like I needed to go down some more. -5. There we go. So again, this picture is not exactly accurate because this is an X and Y picture. I need to figure out where that intersection is. Without a calculator, we didn't do this yesterday, but without a calculator to find the intersection, you would just set the two equal to each other and solve for x. But I have a calculator, so I don't want to do that. I just want to remind you that it can be done, but since you're using the calculator for everything else, use it for the intersection.
Does it not matter what the graph is?
Well, you know what? If you really wanted to be creative, we switched x and y. So how about that?
Is there anywhere on the test where we have to draw the x?
Well, you could argue that this is the correct graph, because I labeled the axes correct now. Well, actually, that's not right, because what I graphed, well, I don't know. You're going to be okay, because what we're looking for is the right integral in the right area. Let's see, the squared one is the parabola, the line one is the bottom one, so y1 minus y2. And again, you do that so often, you don't have to, once it's in your calculator, you don't type it, you just go grab it and change what you need to about it. Like 0 to 3 now instead of 0 to 1. y1 minus y2, 4.5. Again, with the symmetry, like number 9 is going to have some symmetry to it. So you can go from left to right, or you can do half of it and double it if you recognize what's going on. Anything else on the front?
I guess, I don't know if we need to do this whole problem, but with number 3, I got it, like, they intersect at 0, which is the area of 0.
They intersect at 0. Oh, number 3 is tricky because you need to look very carefully at the graph. Because
Can you zoom in or something?
you have to zoom in.
Oh, okay.
Because,
Not there with the-
shoot, I don't remember which way it goes. But one of them's higher than the other one. Thank you. One of them's higher than the other one from 0 to 1. So it's just this little bitty fingernail in there. And even if I don't remember which one it is, if I get it backwards, it'll only be the sign that's wrong. Let's see, I think the x squared would be bigger. So yeah, I did this one right. So yeah, this one you'd have to zoom in, because if you're zoomed way out, it looks like that, and you're like, well, I can't see anything. Well, you need to
I thought it was maybe a trick.
to zoom way in on that and figure out what's going on.
Like the same number and integral.
Yeah, you're right to be worried about tricks. Yeah, like there's not really a bounded area. Do I need to do 13? Find the value of b if the vertical line x equals b divides the region between, there's another typo, x equals y equals 16 minus 2x, and the x and y axis in the two equal areas. Okay, 16 minus 2x. Well, again, sometimes you got to play with your window because nothing showed up right there. But I know this one's going to start at 16, so my window, my Y max should probably be up at 16, or maybe a little higher. And then I don't know how far out to go. Let's just see what that gives me. That's pretty good. So I know it starts at 16. I could find an x-intercept there on the calculator, or I could just do this one by hand and be like, oh, when x equals 8, it's at the bottom. So find the value of b that divides the region into two equal areas. Oh, okay, so somewhere, let's see, x equals b is a vertical line. So somewhere roughly in there, right? It's not going to be at 4 because that wouldn't make equal areas. It's going to be less than 4. But somewhere in there, these two areas are equal to each other now. So that first area would be 0 to b of y1. And the second area would be from b to 8 of y1. And that would be the setup but do not solve part of the problem. Because this one you could solve, because you could actually integrate 16 minus 2x, by hand. And it wouldn't even be terrible. It'd be 16x minus x squared, and then you'd plug in 0 and b and 8. It'd be a lot of algebra, but that's why I switched it to setup but do not solve.
And then the ones right above it, with the less than equal to, is that just bounds?
That's sort of bound, so I know I'm only going from 0 to pi.
Okay.
And chances are, because there's sines and cosines, I haven't looked at it, so I don't know, but this might be a place where one of these is on top for part of it and the other one's on top for a different part of it. But I'm definitely only looking from 0 to pi.
Okay.
Outside of that, I don't care.